Okay, today we're going to have a look at further equations of a line. Okay, so we've already had a look at, in our last lesson, a couple of equations of a line. We looked at the normal equation, which is y equals mx plus b, where we have a gradient of m and a y-intercept of b. And we looked at the general form of a line as well a little bit, where we've got all our information over to the left-hand side and it equals 0. Would have been ax plus by plus c is equal to 0. And that one was the one we called the general form. But there's another way that we can actually look at an equation of a line, or another formula that we can use, and it's called the point gradient formula. And this relates to exercise 3.06 in our book. Now, the equation of a straight line can also be given by, and it's y minus y1 is equal to m and x minus x1, where m's our gradient as before, and x1 and y1 are the points. So we're only substituting into that equation for the x1 and the y1 and the m. The x and the y stay as x and y in that formula. So let's have a look at how we might be able to use that. I guess the thing with this equation is we can often get away without using this point gradient form and often just use y equals mx plus b. But let's have a look at how we might do the example below, maybe doing it both ways. Okay, our example says find the equation of the straight line with gradient 2 and passing through the point minus 1 and 5. So let's use the point gradient form and write that one down. So y minus y1 is equal to m x minus x1. This point here is our x1, y1. Let's pop that in, and we've also got a gradient of 2 there. So popping that straight into our equation, we get y minus y1 is 5, and that is equal to m, which is 2, outside of x minus our x1, which is minus 1, and that's going to be minus 1, so that will become a plus 1 in that bracket. So what we can do now is expand and add 5 to both sides. Let's just start with expanding. We get 2x plus 2 on the right hand side. We'll add 5 to both sides, and we'll end up with y is equal to 2x plus 7 when we group our 5 and our 2 together. Now that was using our point gradient form for this formula here. But you might decide or not remember that formula at that point in time, and we could try the other way, our old-fashioned way. Y equals mx plus b. Now, what we know to put into this formula so far is our gradient, which is 2. So I can pop in y equals 2x plus b. But I don't know what b is yet. So what I then need to do is I need to put in my point, or sub in my point, minus 1, 5. Well, that's my x and that's my y to find our b. So that would mean that 5 is equal to 2 times our minus 1 plus b. So 5 is equal to minus 2 plus b. Let's add 2 to both sides, plus 2, plus 2. So we end up with a b is equal to 7. So it's the same equation as before. In here, we've got y equals 2x plus b, and b is 7. So y is equal to 2x plus 7. A lot of people say, well, why do we actually need to use the point gradient form? I actually think in this case, the point gradient form is a lot easier. You're just popping in information into one equation and solving it. Here we had to pop it in twice. We popped our gradient in and then our point. So I think it was a little bit messier. So that's why we would use the point gradient form over our normal y equals mx plus b. Now, in our HSC, on our formula sheet, we won't be given any of those formulas, the point gradient form, the y equals mx plus b, or the general form of an equation. So we'll need to remember those. But let's move on to the next point here. A line through 2 given points. Okay. When finding the equation of a line through 2 points, first find the gradient and then find the equation of a line using the point gradient form. So for all our formulas for the equation of a line, we need a gradient. Okay, so if you haven't found a gradient, at some point you're going to need to do that. So here's our first example. We're given the points A, which is the point 2 minus 1, and B, which is the point minus 4, 6, and it asks us to find the equation of a line. There, again, are a couple of ways you can do it. I'm going to name my points here, but step 1, let's just have a look at the gradient formula for a line. And I just want to have a look at that and show you something which we haven't looked at yet. The formula that we used for gradient, it's rise over run, but we said it was y2 minus y1 over, x2 minus x1. Now, just for interest's sakes, let's say we multiplied both sides by the bottom here, x2 minus x1. On this side, they'd cancel out, and on the other side, we'd end up with an m, x2 minus x1 is equal to y2 minus y1. Now, if I just quickly swap those two sides around, and I get y2 minus y1 is equal to m x2 minus x1, just popping the y's on the left. Have a look at that formula, and then I'll jump back up to our formula up here, the equation of a straight line. So here we've got y minus y1 and x minus x1. Here we've just got y2 minus y1 and x2 minus x1. But the formula in gist is the same, isn't it? So that's basically where our point gradient form comes from. It comes from our gradient of a line formula. So that might be something that you may need to use at some point. Now let's have a look at our question again. So we've got these 2 points A and B. We've got the A giving us x1, y1, and B giving us x2, y2, and asks us to find the equation of a line. So step 1, we need to find m. So m is our y2 minus y1 over x2 minus x1. Popping those in, we get 6 minus minus 1. Remember, when taking away a negative, there's a minus already, so we've got a double negative. On the bottom line, it's x2 minus x1, so minus 4 minus 2. 6 minus minus 1 is 6 plus 1, which is 7. And minus 4 minus 2 becomes minus 6. So our gradient is minus 7 over 6. That doesn't simplify down anymore. Now, a couple of ways we can do it. We can use either of these two formulas to find our equation of the line. We can substitute straight into our point gradient form using one of those points, A or B, or we could pop into y equals mx plus b, our gradient, and then use one of those points. So it's basically going to be the same thing anyway. So maybe we'll use our point gradient form, and we might use our point A to pop in there. So we'll go y minus y1 is equal to m x minus x1. So y minus our y1 is a minus 1, so a minus 1 becomes a plus 1, is equal to our m, which is minus 7 6, lots of x minus x1, which is 2. Okay, so what we might find in this case is it was a little bit easier to use just a straight out y equals mx plus b. I think would be a little bit easier. But let's keep going and we'll see how we go. I'm going to take one away from both sides here. Take one away. Y is going to be equal to minus 7 6, x minus 2. I've got a minus 1. I need to open up my brackets here and see what we end up with. Y is equal to minus 7 6x plus, because I'm going to minus and a minus together, plus 14 over 6 minus 1. Let's group together our 14 over 6 minus 1, and that will give us a value of, I might just go into a new line here because we're running out of space. That will give us that y is equal to minus 7 6x plus, that'll be 8 over 6. Now we could multiply through by 6 to neaten that equation up and get it into a general form if we liked. We could leave it like that, but if I multiplied everything by 6, I end up with a 6y equal to minus 7x plus 8. If I pop that into general form, I'd end up with 6y plus 7x minus 8 equals 0. Let's have a look and see if we could do it using the other way now. Okay, so like I said, you could also elect to find that equation of the line using y equals mx plus b and one of the points, and I've just taken the first point, 2 and minus 1. So if I pop in my gradient, which was minus, what was it again? Minus 7 6x plus b. So that's what my equation looks like. I don't have a b yet, but I could pop in my x and my y into here and find out what my b is. So y would be minus 1, and that's equal to minus 7/6 times our x, which is 2, plus b. Minus 1 is minus 14/6 plus b. So let's just add 14/6 to both sides, and I'm going to end up on this side minus 1 plus 14/6 is equal to b, which is exactly the same as what we got over there. So my b is going to be 8/6. That gives my equation y is equal to minus 7/6 plus 8/6, which is exactly what we got on this side. And I could actually get that into a general form if I like. So actually this way here is a little bit quicker, I think, and mathematically a little bit easier than our first formula. But you get to choose, and sometimes one will be a little bit easier than the other. And you just need to know both of them. Okay, let's look at our quick quiz number 6. Find the equation of the line through 6 with a gradient of minus 2. Okay, so we know that m is equal to minus 2 on this question. And I don't think this question's got enough information in it, but it says find the equation of the line through 6. I'm going to assume when it says through 6 that that's our y-intercept. That's what we're going to assume in that case. So our b is going to be 6. So let's pop it straight into y equals mx plus b. So y equals minus 2x plus 6. And these go straight into there. That's a nice and easy one. Okay, the next one. Find the equation of the line passing through 3, 4, and minus 1, 3. So step 1, we need to find a gradient. We always need to find our gradient. We'll pop that into our gradient formula. I'm going to call that one x1, y1, x2, y2. 3, take away 4, over minus 1, take away 3. 3 take away 4 is minus 1. Minus 1 take away 3 is minus 4. 2 negatives make a positive. We end up with a quarter for our gradient. Okay, that's step 1. We now need to pop into a formula. I'm going to use our mx plus b formula because that one's looking really nice. And I'm going to pop in our first point there in a second. So I've got y is equal to 1/4 x, or x over 4, plus b. Let's find our b by popping in our 3 and 4. Y is 4. X is 3, so we've got 3 on the top, 4 on the bottom, plus b. Take 3/4 from both sides, and I'm going to end up with a b, which is equal to 4 minus by 3/4. Okay, 4 minus by 3/4 is 3 1/4, which is 4 3 12, which is 13 on 4. So our equation is going to be y is 1/4 x, or x over 4, plus 13 over 4 is our equation of the line there. Okay, so likewise, there's another one over here underneath. You can do that exactly the same way. I'm going to get you to pause the video and have a go at that yourself, and I'll pop the answer up for us. Once you've had a go, you can check your answer against mine. So you're probably thinking you got the wrong answer there, but the gradient was 0, so we ended up with a 0x plus b, and our b was 2, so y equals 2 was that equation. For 4, find the equation of the line parallel to the x-axis through the point 5 minus 1. So if you're not sure, let's draw a little picture. X, y, a line, and it's going to be going through the point x is equal to 5 minus 1, so it's going to go through a point there, 5 and minus 1, and it's parallel to the x-axis. So it's going to look like that. So no matter what our x value is, our y is going to be equal to minus 1 all the time. That would be our equation of the line for that one. Okay, let's look at the next one. Find the gradient of a line which makes an angle of 30 degrees to the y-axis in the positive direction and through the point 1, 1. Okay, so we just need to change that question a little bit because there's a little bit of a mistake in there. It needs to make an angle of 30 degrees to the x-axis through the point 1, 1. So let's have a look at my diagram. There's my line. There's our point 1, 1. Making an angle of 30 degrees. Our formula for our gradient with angles is m equals tan theta. So we got m equals 10, 30. So popping that on your calculator, pressing in 10, 30, m is going to be equal to 0.577 to 2 decimal places.